Okay. I am actually going to try sitting down today because I think I'm getting some weird muscle imbalance from like leaning over to write on this iPad. So I gotta try sitting down. I don't know if it's going to help. I actually don't even know if my shoulder hurts because of this, but that's what I think it's going to be. So I'll just try sitting down today and see what happens. Okay, and I'll see how long I can keep this camera rolling. Self-conscious. Okay. So we're going to start talking about another type of function. Remember, we did derivatives of a lot of different functions. We did polynomials, we did logarithmic and exponential functions, trig functions, and now we're going to talk about inverse trig. And before we even go over this, I'm just going to do a very, very quick review on what these functions are. So if we recall, about functions, maybe from our pre-calc class, we have pairs of functions that are opposites of each other, and we call them inverse functions. For example, like addition and subtraction are inverses of each other. They cancel each other out on both sides of the equation. Multiplication and division are inverses of each other. They cancel each other out. We actually had one that we've talked about before. E to the x has an inverse function. Does anyone remember the inverse function of e to the x? Yeah, ln of x. Yeah, so ln of x is actually the opposite or the inverse of e to the x, and it cancels out e to the x, right? And e to the x cancels out ln of x. Okay, just like these functions are inverses of each other, well, we have inverses of trig functions. Okay, now I know this might be very a long time ago when you've learned about these, so I'm just going to show you what they're called and kind of the notation that we use for them. Okay, so let's start with sine. The inverse of sine is sine -1 x, and we don't say the -1. We actually just say sine inverse x. Okay, so that's kind of how we say this function. And if we don't like writing the -1s, instead of writing sine inverse, we can also write arcsine. Okay, so arcsine and sine inverse, they mean the same thing. Okay. Now the notation is pretty much the same for any trig function that we use. So like cosine, tangent, cosecant, they all use the same notation as well. Okay, the thing about these functions is since they're inverses, they cancel out their respective trig functions. So for example, if I took like sine inverse of sine of x plus 1, what would be left after I do this operation?
X plus 1.
Yeah, x plus 1. Okay, so just a reminder, these functions cancel out their paired trig function. Okay, just a little reminder for you guys. I know that there's a -1 in the notation for sine. This does not mean I'm taking sine to the power of -1. Okay, so the inverse notation doesn't mean to the power of. Okay, this means on the left, it means sine inverse. Okay, so that's how we say that. Okay, this is sine to the power of -1. So another way of saying the right-hand side is literally 1 over sine x. All right, passing this back. Okay, so just the difference between the one on the left and one on the right, they don't mean the same thing. Taking sine to a power looks a little bit different than sine to the -1. Okay, so because we can find the derivatives of sine functions, we can also find the derivative of inverse trig functions. And there's a lot of them, okay? And I know it looks a little crazy. To make this easier for you, in this class, we will be using cosecant and secant. I'm going to say for a test or quiz, I'm not going to require you to memorize these two, okay? So don't memorize these if you don't want to. But the other 4, I do want you to know. If you ever take Calc 2, you'll probably see tangent a lot. You'll see the derivative of inverse tangent a lot, and you'll probably see the derivative of sine inverse as well. Okay. I think that's all I wanted to say so far. Any questions so far? Sounds good. Okay. Let's turn our page here. We can put all these derivatives together. Okay. So let's do our first example here. I want to find the derivative of sine inverse of 5x. Okay. What rule do you think I'm going to use here? Chain rule, right? There's an inside and there's an outside. Okay. So let's figure out what the inside is. What is the inside function? 5x, good. And what's the outside? Yeah. Sine inverse or sine to the -1 or whatever you want to say. I like saying sine inverse because it takes away that idea of that sine is raised to a power. Okay, we're not raising sine to any power here. Okay, so derivative of the outside.
Oh, sorry.
Yep, 1 minus, and not x squared, but our box squared. All right. Okay, so that's the derivative of our outside function. What's the derivative of the inside function? 5, good. Okay. Now, when I'm plugging things into my box, I'm going to put the 5x in parentheses because I'm raising that whole thing to a power, and I don't want to get mixed up and think that only the x is being raised to a power. I'm going to keep everything in one group here. Okay, so cleaning this up, we get 5 over the square root of 1 minus 5x in parentheses squared. Okay, and because I feel like it, why don't we just expand this out a little bit? I can square the 5 and square the x, and this becomes 5 over the square root of 1 minus 25x squared. Any questions on example 1? All right. I'm going to give example 2 a shot. So try example 2. Very similar to what we did in example 1, maybe a slight bit harder. But I think you guys can work. I see some good answers. I want to go over this step by step though. So I think I'm going to do this one in front of the class here, and then we'll get people to write stuff on the board as we go along here. Okay, so I know I gave you a different version of how we say this trig function here, but our tangent is still inverse tan. Okay, so if it makes you feel a little bit better, you can always rewrite this as tan -1 square root x. Okay, so we can always do that. Okay, so looking at this, what sort of rule are we going to use? Product rule, quotient rule, or chain rule, right? Because there's an inside, the square root, and then there's an outside, which is the tangent or inverse tangent, right? Okay, so let me write out this real quick. We've got the inside function, which I kind of just gave to you, but it is the square root of x, right? And the outside function is the inverse tan. Okay. All right, let's piece this together here. Let's do the derivative of the outside. What is the derivative of the outside?
1 under 1 plus x squared.
But instead of x, we're going to use our box because we're not actually using x this time. Okay, and then we have to multiply by the derivative of the inside, which we haven't done lately with the square root function. What's another way to rewrite the square root of x? X to the 1 over 2, good. Okay, so now that we have something written in something that we can use the power rule with, what's the derivative of x to the 1/2? Using the power rule.
1 over 2x, -1 over 2x.
Perfect, but not 1 over 2x in the exponent, right? Just x to the -1 over 2. Okay, good. Okay, now I can fill in my box with the inside. Should I use the square root of x or x to the 1/2 on the inside of the box? Which one is more comfortable for you guys? don't know. I like using the square root of x. It doesn't really matter, but it makes me more comfortable to use this notation instead. Okay, but you can do whatever you like. Okay, let's clean this up a little bit. Okay, we've got, let's see, 1 over 1 plus the square root of x squared. What is the square root of x squared? X, good. So this becomes 1 over 1 plus x, right? And then what's x to the negative 1/2? What would that be?
1 over 2x.
Oh, you're doing the derivative, but how can I clean up x to the negative 1/2?
Put it on the bottom.
Good, put on the bottom. And what does x to the 1/2 become? What's another way to write?
Positive. X, 1 over x, or 1 over square root of x.
Good, you're good, okay. Yeah, so the negative brings it to the bottom, the 1/2 turns it into a square root. Okay, so let me just clean this up even more. This becomes 1 over 2 square root of x times 1 plus x. Okay. All right, lots of stuff going on there. Any questions on example 2? All right. Oh, yeah.
Oh, never mind, I just factored it.
Oh, yeah, you can expand it out if you'd like to.
I expanded it out and then I factored out square root of x.
Oh, okay, I see. Huh. And I think that would work.
But I got like my first like answer is that.
Okay, yeah, you can do anything to this. This is probably what I'd look for as an answer, but if you have something equivalent to it, that's totally fine. Okay, let's do this example here, which is a little bit confusing. Okay, and I'll show you why. Okay, I want to find the derivative of 1 over sine inverse of x. Okay, now we haven't dealt with derivatives with fractions. We usually turn it into something we can use the power rule for. Is there a way I can rewrite this in terms of no denominators?
Inverse sine x to the power of -1.
Perfect. This is inverse sine x to the power of -1, right? To bring something from a fraction out of the fraction, we just need to raise it to a negative exponent. Okay. Now this is a little tricky, right? Because we have 2 -1 exponents here, but only one of them is actually a power, okay? Now, if I take a look at this -1 here is just telling us that this is sine inverse, okay? This -1 is telling us that we're raising it to a power, okay? So don't get confused with this -1 symbol here, okay? What rule am I going to use? Product, quotient, chain rule? Chain, right? It looks like we have an inside and an outside thing going on here. What is my inside function? Inverse sine x. What's my outside function? Box -1. Good. So I'm raising something to the negative first power. All right, let's try to take the derivative of this. What's the derivative of my outside function?
-1 block to the power of -2.
Perfect. -1, my block times the power of -2. Okay. And then what's the derivative of the inside?
Over square root of 1 plus -1. Oh, 1 minus -1.
1 minus, yeah, 1 minus x squared. Good. Okay, so that's just the derivative of sine inverse using our chart in the front. Okay, filling in my blank here, I guess I would put sine inverse on the inside. And I'm just going to put it in parentheses because I'm taking that whole thing to a power. It looks really bulky, so parentheses might be useful here. Okay, so cleaning this up, I've got, let's see, -1, maybe I can put that on top of the numerator here, over the square root of 1 minus x squared times sine inverse x to the -2. Okay, what can I do when I have a negative exponent? So the -2, what does that do to sine inverse?
Goes down to the denominator.
Goes down to the denominator. Good. So now I have -1, the square root of 1 minus x squared times sine -1x squared. Okay. Now here's where things get a little tricky. I know that when we square sine, we write it like this, like sine squared x. We can't really do that with inverse trig functions because there's a negative sign like in that exponent spot. So we're actually going to just keep the parentheses around sine inverse and just square it. Okay, so that means sine x or sine inverse x squared. Okay, any questions on example 3? Okay, so we can actually do the chain rule where the inside function is a inverse trig function. Very similar to that is example number 4. This is with tangent, and I'll give you a few minutes to work on this one. This question was inverse tan raised to the power of 2. Mason did a great job of writing out his answer. Mason, do you kind of want to take us through your steps here?
So I just did the chain rule.
Mhm.
Inverse tan
Mhm.
squared, and then I multiply the 2 arctan x on top of the derivative of arctan x.
Mhm. Perfect, right? So we ended up here. Just a little reminder, and I know I keep repeating this, but this -1 here means arctan, right? It means the inverse tangent. It doesn't mean -1. So don't bring that to the bottom, even though it's very tempting to do that. This is a function in of itself, and you're not moving it to the top or bottom, anything like that. Okay. Any questions on example 4? Great job, Mason. Let's do example 5 now. Okay, now, of course, you can work on this. I saw some people doing good job on this as I've been walking around, but since this one's a little bit different than what we've been doing before, I do want to go over this one real quick. Okay, so let's say we have a secant inverse or inverse secant of x squared. What rule am I using here? Chain rule, good. Looks like we have a little pattern here today. What's the inside function? X squared. And what's the outside function? Secant inverse, good. Okay, so when we do this, we want to find the derivative of the outside. What is the derivative of inverse secant of box?
1 over
Not x, but
box.
box. Thanks.
Square root of x squared.
Square root of x squared, or not x.
That's also box.
Yeah, that's why I put this in there. It's a little bit tricky, right? So I know it looks a little weird, but since we have 2 x's in the derivative of this function, there's actually going to be 2 boxes in this derivative of the function. Okay, so I know secant looks a little weird because there's 2 x's in the derivative. We're just going to treat it like we would any other function and plug the same thing in to x wherever it is. Okay. Okay, so we have the derivative of the outside. What's the derivative of the inside? 2x, good. Okay, once we're finished doing this, we can fill in the box and put x squared wherever we have a box here. Since inside the square root, I'm taking the square of the box, maybe I should put this in parentheses, okay? Because I have a big group of things being squared, I should put things in parentheses here. Okay. So it looks like we got 2x on top. Can't really do anything with the x squared yet. We got the square root of, what is x squared squared? X to the fourth minus 1. Okay. Looking at this, anything else we can do to simplify this?
Could take the x out of the square root.
Can't actually do that unless we factored it and we had 2 matching factors. Any other?
X.
You mean from the top and the bottom, right?
Yes.
Good, right? Because we have an x squared on the bottom and an x on top, we can cancel these out, cross out the x, cross out the square, and we're left with 2, oh my goodness, 2 over x times the square root of x to the fourth minus 1. Okay, once we're here, there's actually not much else we can do. So this is actually our final answer to our question. Okay. Any questions on example 5? All right, moving forward. We have example number 6. And this one's a little bit crazy. I'm not really sure why I put this on here, but let's do this. So over here, we have this square root of 1 minus x squared times arc sine of x. What's the big rule that we're going to be using for this? Product rule, because we have a product of things, right? So this is going to be product rule. But let's look a little bit closer. When I do the product rule, I'm going to need to take the derivative of arc sine. I'm also going to need to take the derivative of the square root of 1 minus x squared. Am I going to have to use a rule to find the individual derivatives? And which rule is that? Chain rule, right? And that's going to be used for this derivative here. Okay. So when I do these rules, which rule am I going to use first? Am I going to use the product rule first, or am I going to do the chain rule first? Actually, that's kind of a bad question because some of you can do this in different ways. I think we can see that the overarching rule here is the product rule. And while we do the product rule, we're going to eventually use the chain rule when we find one individual derivative. Does that make sense? Sound good. Okay. Because I have so many crazy functions going around here, instead of just jumping into the product rule, which I know some of you can do, and that's fine, I'm actually going to set myself up and keep myself organized here. Okay. When we use the product rule, we have an f and a g. F is usually the first function, g is usually the second, but it doesn't matter which one I apply f to and which one I apply to g to. Okay, so I know that f is the square root of 1 minus x squared. I know that g is arc sine. Okay, why don't I find the derivative of f so that when I do the product rule, I can just stick the derivative I find in the product rule and I don't have to mess myself up a little bit too much, okay? So f prime would be the derivative of f, and we did say we have to use the chain rule, okay? What's the inside of f? Yeah, 1 minus x squared, okay? What's the outside? Square root of something, exactly. All right, and because I can't find the square root, or I can't find the derivative of a square root function like by itself, like I don't know that off the top of my head, I can rewrite this as box to the what power? 1/2. I heard a negative 1/2. It's actually just positive 1/2 here because it's on the numerator. Okay, negative comes in when we have a denominator. Okay, so when I find the derivative of f, I need to do the derivative of the outside first, right? And what's the derivative of the outside? Perfect. And then I'm going to multiply that by the derivative of the inside. And what is that derivative? Negative 2x, perfect. Okay, next, if I want to fill in this blank that I put in, I would just stick the inside into this box. So I would do 1 minus x squared, and maybe I should keep it in parentheses because I'm taking it to a power. Okay. All right, cleaning this up, it looks like the 2's will cancel out, right? So I'm going to be left with negative x times a group to a negative power, which I can write in the denominator, right? So negative x over 1 minus x squared to the 1/2, okay? And another way of saying 1/2 is a square root, right? So this is negative x over the square root of 1 minus x squared. Okay, so I found the derivative of f itself. I can also find the derivative of g. What is the derivative of arc sine?
1 over square root of 1 minus
X squared. Perfect. All right. So I have all my parts. And I know that the product rule says that FG prime is FG prime plus GF prime. Okay, I have all my individual pieces. I can kind of just piece them together. So I know that F by itself is the square root of 1 minus x squared. I know that my derivative of G is 1 over the square root of 1 minus x squared. That's convenient. Okay. I can add on G, which is arcsine of x, and multiply that by the derivative of F, which I found in blue, negative x over the square root of 1 minus x squared. Okay. Anything I can do to clean this up a little bit?
You can cancel out the square root of 1 minus x squared.
Yeah, right. This question was very conveniently made so that I can cancel out those two. And I guess I'd be left with 1 here. I've got a negative x, and I'm just going to turn that into a minus sign. And it looks like on top we have x, arcsine, x on top, and the square root of, oh my gosh, 1 minus x squared on the bottom. Okay. Any questions on example 6? Okay. So finding the derivatives of inverse trig functions is literally the same as finding the derivatives of any other types of functions. It's only a little bit more difficult because we have like fractions going on, square roots going on, but overall it's basically the same thing. Okay. Before I give you your quiz review, there is one example that I want to go over that you might see in your homework that I haven't really talked about a strategy to do yet. So let's go down to example 5 real quick. Okay, so I'm going to write a note here. I put this on your homework. I think I made it a little bit hard. So I want to go over this one. And if you see this question on your homework, then you can go back and see how I did this. Okay, so we have arctan of the square root of x minus 7. Okay, what rule do you think I'm going to use here? Chain rule, because I have x square root of x minus 7 and I have arctan. So this is definitely the chain rule here. Okay, but then if I look at the square root of x minus 7, I can't do that derivative in my head, right? What rule am I using for this? The chain rule, right? So now what I have is I have a derivative where I'm using the chain rule, but then in order to do the chain rule, I also have to do the chain rule. So I'm doing the chain rule kind of twice embedded inside of itself. Okay, let's see how we would actually do this. Okay, so let's look at the bigger chain rule. So the arctan of the square root of x minus 7. Let's work with that, and then we can kind of go in as we continue on with this rule here. Okay, so looking at the arctan function, what is the outside function? Let me start with the outside first. What's the outside function? Arctan, good. Of my box here. Okay, and what's my inside function? Yeah, square root of x minus 7. Okay. Okay. So next what I have to do is I know I'm going to do the derivative of the outside times the derivative of the inside, but maybe I should find the derivative of the inside first. Okay, so maybe on the side here, I'm going to find the derivative of the inside. Okay, now we said that we have to use the chain rule here as well. So I'm going to do the inside of the inside. What is the inside of the inside? Not 1, but not 0. What's the inside of the square root of x minus 7? X minus 7, good. Okay, oh, I think you were doing the derivative of that. That makes sense. Okay, all right. Next, we need to do the outside of the inside. And what's that function? Square root, right? So it's the square root of our box, or box to the 1/2, right? Okay, so let's do the derivative of the inside first, and then we'll go back to what I have in red. Okay, So I guess what we have to do is we have to do the derivative of the outside of the inside, right? So what is the derivative of the outside of the inside, or my box to the 1/2 function?
1/2.
Mhm.
Plus.
Perfect. 1/2 box negative 1/2. And then what is the derivative of the inside of the inside? Good. So that's 1. Okay. So I'm multiplying these two together and filling in my box now. I know that x minus 7 goes here. Okay. So just cleaning up the derivative of my inside in blue here, it looks like I have 1/2. And since I have a negative exponent with a negative 1/2, I'm going to bring that to the bottom. The 1/2 makes a square root. So I'm left with 2 times the square root of x minus 7. Okay. So I found the derivative of my inside function that I wrote in red. Now we can apply the chain rule on the outside. Okay. So chain rule says take the derivative of the outside. What's the derivative of arctan of box? Good, but instead of x, it's the box, right? Okay. And then I have to multiply that by the derivative of the inside, which I just found to be 1/2 times the square root of x minus 7. Okay. Putting this together, looks like I'm going to stick this inside into my red box here, the square root of x minus 7. Okay, and I'm multiplying all of this together. Anything I can do to simplify this
You would pick up the square root
in the first?
arctan.
Yeah, like right here, we have a square root and a squared. Those two are inverse functions, which mean they cancel each other out, which means I can rewrite this as 1/1 plus x minus 7. Right, just take away the square root because I'm squaring it. Let's keep the other part the same. Okay, well, looks like we have 1 minus 7 going on in our first part. So I can add the 1 and 7 to get 1/x minus 6, good, times 1/2 square root of x minus 7. And just to make this look a little bit cleaner, we can kind of combine our two fractions into one to get 1/2 x minus 6 times the square root of x minus 7. Okay. Any questions on how I got this example? Okay. I think I was a little bit mean putting this on your homework because not only does it involve inverse trig, but it also requires you to do the chain rule twice. But hopefully, if you ever get stuck on this on your homework, you can look at this example. It does use a little bit of different numbers, but I think you can use this to help you study. All right. Any questions? All right. I think we do have a quiz review to go over. Now, of course, I will post the answers to this later today. So if you have somewhere to be, I'm not offended if you leave. But if you want to work on this now, I will